sand molding and what is advantages and disadvantages along with ceramic molding and advantages and limitations, and shell molding and advantages and disadvantages. So these three types of moldings we discussed. See here first cement bonded molding. Okay, so here the Portland cement. Okay, so in cement bonded molding, so the Portland cement of 10% and water 5% are added to the synthetic sand. Okay, so it requires less ramming. Okay, it requires less ramming. Why? Because here we use the cement, so cement having a strong, so it will easily compact. Okay, so here the setting time is about 72 hours. The setting time is about 72 hours. The mold is high strength and as well as high. Why? Because here we are using this Portland cement. So that is the reason why the strength of mold is very high, and also it gives hardness. It is having high hardness. Okay? A separate cope and drag are prepared. And assemble. A separate cope and drag prepared and as well as assemble. Okay, vents are made for escapement for flue gases. Why this vent? By using a vent rod we can place the vent holes. Okay, these holes are used for escapement of flue gases. These gases are used for escapement of flue gases. Okay, so it is employed for small to large castings. It is employed for small to large casting. This is the procedure for cement bonded molding. So here we have some advantages with the cement bonded material molding. See, a smooth surface finish is obtained. A smooth surface finish is obtained. Machining is not necessary. So machining is not necessary. Most of the sand can be reused. Okay. So here we have a few disadvantages. So difficult to knock out of the flask. Why? Because it is a cement bonded material. So we are using the cement, Portland cement. So that what happens? So it becomes stronger. Okay, the mold becomes stronger. So after making of mold, after making of the casting, so if you want to break that mold, so it will become stronger. Okay, so it is difficult to break it. Okay, so that is a disadvantage. So and next type of molding is ceramic molding. Okay, so this ceramic molding, it is employs a metal pattern. Okay, it is employs a metal pattern. So a metal pattern is kept in the flask. A metal pattern is kept in the flask. A thick slurry of refractory metal is applied. A thick slurry. So here we use the slurry. The slurry is of refractory material is applied on the pattern. Okay, so this generally ceramic molding is generally applied for the metal patterns. Okay, so here we use the slurry. Actually, what is slurry? So this slurry consisting of fine grained zircon and silica, and as well as silica. Okay, so a coarse breaking slurry is filled in the flask. Coarse breaking slurry is filled in the flask. Okay, so it sets within 3 to 5 minutes. Okay, so it completely set. It will take say 3 to 5 minutes. Within the 3 to 5 minutes it will be ready. Okay, so now the pattern is withdrawn. So the ceramic mold is removed from the flask. Okay, so it is treated with the chemical catalyst. It is heated at 980 degrees centigrade. The molten metal is poured in the mold. Okay, after solidification the casting is removed. So this is about the ceramic process. So it is generally used for metal patterns. Okay, so it is generally metal. So here we are adding we use that is a slurry. Okay, so slurry is a fine grained zircon and silica. So within a few minutes it will complete the mold. Okay, so within 3 to 5 minutes it will be set. Okay, so the pattern is withdrawn. So the ceramic mold is removed from the flask. Okay, so it is treated with the chemical catalyst. Okay, so it is heated at 980 degrees centigrade. The molten metal is poured in the mold. Okay, After removing the mold from the pattern, so then the molten metal is poured. Say here we can able to observe there is ceramic molding, there is a drawing. Okay, so here the file backup. So here ceramic facings are there. Okay, so here we have used the cope and the parting line. Okay, and as well as the drag. Okay, so by using this slurry we can make to form the that is this is ceramic facing. Okay, so that will be removed from the mold, then we can pour the molten metal. Okay, so that is the things. So here we have the few advantages. What are the general advantages we have? So high quality and precision casting can be produced. High quality precision casting can be produced. Okay, no matching is required. No matching is required. So all types of materials can be casted. All types of material can be casted. Intricate casting with thin sections can be produced. Intricate casting with thin sections can be produced. So these are the few advantages. So high casting and precision casting can are produced. Okay. No matching is required. No matching is required. All types of material can be casted. All types of material can be casted. So intricate casting with thin sections can be produced. Intricate castings with thin sections can be produced. So having along with this, we have a few disadvantages. So it is expensive process. It is expensive process. Defects at parting lines may occur. It is expensive process. Defects at parting line may occur. Okay. So applications. So what do you have? A few applications with this ceramic molding. So here this ceramic molding can be applied in a various various places. So the first here we used means it is extrusion dies. Okay, used in extrusion dies and die casting dies. Okay, extrusion dies and die casting dies and impellers for pumps, parts for automatic reactors. So this is about the ceramic dies. And then next one is a shell molding. Okay, so shell molding, so mixture of sand and resin is spread around. Okay, so mixture of sand and resin is spread around the heated metal pattern. So here in shell molding also we use the metal pattern. Okay, so here that mixture, so means combination of sand and as well as resin. Okay, so is spread around the heated metal. So before going to make the molding, the metal pattern will be heated. Okay, after heating that metal pattern, so we apply this mixture that is called sand and as well as resin over the metal pattern. Okay, so then if you are applied over the heated metal pattern, so the thin shell is formed. Okay, thin shell is formed. So from the metal pattern, so the thin shell is separated. Okay, so the thin shell is separated. So the two halves of shells. Okay, so two halves of shells are clamped together to form a mold. Okay, see here the shells are formed half. Okay, so after removing the after separating the shell from the metal pattern, so that separated shells are clamped together. Okay, clamped together, then it will forms a mold. Okay, so that is a shell molding process. The name indicates itself, it is a shell molding. Okay, we prepare the shell by using a heated metal pattern. Okay, see after that the preparation of thin shells. Okay, so a fine silica sand. Okay, a fine silica sand is mixed with 5% resin. A fine silica sand is mixed with 5% resin. Fine silica sand is mixed with 5% resin. The resin is a thermosetting material. So here we use the resin is a thermosetting material. So it is poured in the dump box. It is poured in dump box. A metal pattern is heated to 250 degrees centigrade. So a metal pattern is heated at to 250 degrees centigrade. So it is clamped to the dump box. That is called molding boxes. It is clamped to the dump box. Okay, so it is called molding boxes. Here the fine silica sand is mixed with 5% resin. Okay, so the sand is mixed with resin. So the resin is a thermosetting material. So how you can make the shell mix? This is the procedure. So it is poured in the dump box. Here in a figure we are able to observe, here we use a dump box. Okay, so the pattern plates is there, ejection pins are also there. Okay, So the pattern is there. So over which that silica sand and mixed with 5% resin is poured in the metal plate. So it is reversed. Okay. So after reversed, the metal will be pattern comes. Then we can tilt to upside. So from there we can remove the ejecting pins. From there we can separate the shell. Okay. So the metal pattern has the ejecting pins. The dump box is inverted. Okay. Dump box is inverted. The sand resin mixture covers a pattern forming the shell. Okay. Within the 30 seconds, the resin cures and shell is formed. Within 30 seconds, the resin cures and shell is formed. Okay. So that is okay. So a separating thin shell. How the thin shell is separated means after forming a thin shell, the dump box is reversed to original positions. So means it is comes to its initial position. How the initial position is there. Okay. So in the figure we are able to see the three figures are there. The first one is the initial figure, and second one is inverted the dump box. Then third one is so same which comes to its original. That is the initial positions. Okay, so the first one, the metal plate paste, so then it will be inverted. So the metal plates that say as what we can call resin will be dropped down to the metal pattern. So it will form the resin. Okay, so it forms the shell. Okay, it forms the shell within the 30 seconds. After forming the shell, so that dump box will be reversed. Means it will bring to its initial positions. Okay, so within the 30 seconds it will form the thin shells. Okay, see how the separating will be taken place after forming the thin shell, that is a box will be reversed. Okay, brings to its original positions. Then the surface resin mixture falls back into the box. Okay, so whatever the leftover material will be, that will be dropped down to the bottom. Okay, so here we use the ejecting pins. Okay, so the pattern plate is removed. The pattern plate is removed and the shell is ejected out. The pattern plate is removed and the shell is ejected out. Okay, so from that the shell is removed from the box. Okay, see how after forming the shell we can form the mold. See how the mold is formed. So here the mold shell. Okay, mold shell is cured at 320 degrees centigrade. Mold shell is cured at 320 degrees centigrade for few minutes. Okay, so while forming the shell, so it will be cured to 320 degrees centigrade for a few minutes. Okay, so it has a two halves. Okay, it has a two halves are joined together. Okay, it has a two halves and joined together. Adhesive. So adhesiveness is used to join them. Okay, it is a property, it is a cohesiveness and as well as adhesiveness. So by using adhesiveness, so it is used to join them. Okay, so the mold shell is placed in the suitable box. You see, after taking the mold shell, so it is placed in a suitable box. Okay, so it is supported by the coarse sand in the box. Okay, so after placing the mold shell in the box, so the leftover thing will be filled with the coarse sand. Okay, so coarse sand, that sand will give to support the mold shell. Okay, see, then molten metal is poured in shell mold. Molten metal is poured in shell mold. Okay, molten metal is poured in shell mold. So it is solidifies. Okay, so it is solidified and the casting is removed. It is solidifies and the casting is removed. Okay, see here we have advantages. Okay, what are the advantages we have? Say accurate casting with good surface finish. Accurate casting with good surface finish. Okay. So machining is not required. Machining is not required. A thin wall sections. A small hole can be created. Okay, the shell can be reused. The shell can be repeatedly reused and as well as repeatedly. So the shell, whatever prepare the shell, mold shell, that will be repeatedly we can use it. Okay, accurate casting with good surface finish. So by using this we can get the very good surface finish. Okay, so machining is not required, so we can get accurate dimensions, so we need not to remove the extra material from the mold. Okay, so here we can get the thin wall sections. A small holes can be created. Okay, a small holes will be created. A thin shell can be reused and repeated. Thin shell can be reused and as well as repeated. See, here we have a few disadvantages. So the cost of resin is high. The cost of metal pattern. So high cost of metal pattern. So casting size is limited. The casting size is limited. So these are the disadvantages. Okay. So as usually the cost we are using the resin preparation of mold, it will take the resin cost is high. Okay. So the metal pattern is also become high cost. Metal pattern is also high cost. So the size is limited. Okay. So but a small size can be prepared by using this thin shells. Okay. So that is disadvantages. So advantages and disadvantages. So it is very very important. So the separating the shell, how to prepare the thin shells. Okay. And how to prepare the mold. Okay. So mold formation. So by using the thin shells only we can prepare the half. Okay. So remaining half, it is a two halves. By using two halves we can prepare the mold. Okay. So by the two pins, by using ejected pins we can remove the shell from the heated plates. Okay. So that is the thing. So advantages is accurate casting with good surface finish. Okay. Machining is not essentially is required. Okay. Thin wall sections. Okay. Small wall sections, if you are required, so you can use this method very easily. The small holes can be created. If you want to create a small holes, as usually you can go to create a shell can be reused and repeated. This is one of the important thing is that suppose if you go for the repeated operation, same casting if you want to go, so no need to go for the preparation of thin shell again and again. So once if you used, then that can be reused and repeatedly also. Okay, that is the main advantage. So coming to the disadvantage, as usually the resin cost is high. The cost of metal pattern is also high. So you are not going to use the wood or any other material, but here it requires only metal pattern. So that is the reason why the cost of the metal pattern is also usually high. Okay, and moreover the casting size, okay, casting size is limited. So it is limited size only we are going to be produced. Okay, so we are not going to vary the sizes of the castings. That is the main disadvantages. Okay, as usually there are a few applications are also there where it is used for fine castings. So generally it is used in fine castings. Okay, ferrous and non-ferrous metals can be casted. Okay, so the casting size is a few grams to 25 kgs can be produced. Okay, it is a limited operation, so it is casting some few grams to 25 kgs can be produced. Okay. So these are the applications, so advantages and disadvantages, and as usually that is the applications. Okay. So here in today class we will discuss about the three molding processes. One is cement bond and molding, and second one is the ceramic molding, and third one is the shell molding. Okay. So the name indicates the shell, the preparation of shell. Okay. So that is. And tomorrow we'll discuss another type of molding process, that is the special casting processes, that will be seen in next class. Okay, thank you.